Hello guys, welcome to my channel Conceptual Chemistry Demystified by John HBK. Today, let's demystify balancing a redox reaction. Before continuing with the video, I would strongly recommend you to see my previous video on redox reaction basics. It will be helpful in understanding the following lecture. Let's look into our learning objective. Balancing of redox reaction by the following methods: oxidation number method and half reaction method or ion electron method. So let's see what is oxidation number method. Oxidation number method involves the following steps. Step 1. Write skeletal equation and balance the elements other than oxygen and hydrogen. Step 2. Assign oxidation number to atoms and calculate the increase and decrease in the oxidation number and make them equal. Step 3. Balance oxygen atoms by adding water and balance hydrogen atoms by adding H plus ion to the side having less hydrogen atom. Step 4. If the reaction occurs in basic medium, then add OH minus ions equal to the number of H plus ions in step 3 on both the sides of the equation. And step 5. Check the equation with respect to both the number of atoms of each element and the charges. So now let's move on to an example and apply these steps to balance a redox reaction. Now we have a skeletal equation in front of us. Let's assign the oxidation number to each of the elements. Manganese here shows +7, oxygen -2, Fe +2, Mn +2, Fe +3. So we have assigned the oxidation state, and now let's see the increase and decrease in oxidation state per atom. In the case of MnO4 minus to Mn +2, the oxidation number decreases from +7 to +2. So oxidation number decreases from +7 to +2, that is 5 per atom. In the case of Fe +2 to Fe +3, the oxidation number increases from +2 to +3, that is by 1. Increase by 1 per atom. So therefore, to make it equal, I have to multiply this by 5. Now write the equation: MnO4 minus plus 5 Fe +2 plus gives Mn +2 plus 5 Fe +3. Now here the oxygen is not balanced. Now the atoms are balanced but oxygen is not balanced. So to balance oxygen, we put water on the opposite side of the equation. There are 4. So here there are 4 water molecules that to be added. And when you are putting water, there are 8 hydrogen atoms. Since the reaction is an acidic medium, we'll put 8 H plus ions. So now let's check whether the reaction is balanced. 1 Mn, 1 Mn, 4 oxygen, 4 oxygen, 5 Fe, 5 Fe, 8 hydrogen, 8 hydrogen. So the atoms are balanced. Now what about the charge? Let's check out. -1 plus 5 2s are 10 plus 8 1s are 8. This makes up a total charge of 17 plus 17. And here +2 plus 5 3s are 15 plus water is a neutral molecule. Therefore the overall charge is +17. Now we have the charges also balanced as well as the atoms. Now let's move on to our next example. First, we have the skeletal equation in front of us. Let's balance the atoms other than hydrogen and oxygen. So, one copper, two nitrogen, one nitrogen, so I'll put 2 here. Then assign the oxidation numbers. Here copper is +2, here oxygen is -2, nitrogen here is -3, hydrogen here is +1, copper in free state 0, nitrogen in free state combined with itself 0, hydrogen +1 and oxygen -2. Now let's see the increase and decrease in oxidation state per atom. In the case of copper oxide to copper, the oxidation state changed from 0 +2 to 0. That is decrease of 2 per atom. In the case of ammonia, NH3 to nitrogen, the oxidation changed from -3 to 0. That is, it increased by 3 per atom. Therefore, we have to make this multiplied by 3, this multiplied by 2 to make it equal. So, we will write the equation 3 CuO plus, we have already multiplied here 2, so 2 NH3 gives 3 Cu plus N2 plus H2O. Now let's see the atoms copper and nitrogen balanced. Now let's balance oxygen. There are 3 oxygen over here and there's only 1. So to make it 3, I multiplied this by 3. 3 oxygen. This makes up 6 hydrogen. 3 2s are 6 and here I have 3 2s are 6. So the hydrogen is also balanced. And since all are neutral molecule, the charge also is balanced. Let's move on to our next example. So in our third example, we have the skeletal equation in front of us. Bismuth hydroxide reacting with a tin complex giving bismuth plus tin hydroxide complex. Now let's assign the oxidation number. Here bismuth is +3, oxygen -2, hydrogen +1. Here tin is +2, oxygen -2, hydrogen +1. Bismuth here is single, therefore 0. Tin here is +4, oxygen here is -2 and hydrogen here is +1. And the reaction takes place in basic medium. Now let's see the increase and decrease in oxidation number. BiOH thrice converts into Bi, and the decrease in oxidation number is from 3 to 0. Therefore decrease by 3. And in the case of SnOH the whole 3, overall charge -1 gives SnOH the whole 6, overall charge -2. The change is from +2 to +4. That means it is increased by 2. Therefore, to make it equal, I have to multiply this by 2 and this by 3. And therefore, the reaction becomes 2 BiOH the whole 3 plus 3 SnOH the whole 3 overall -1 gives 2 Bi plus 3 SnOH the whole 6, overall charge -2. Now see, our atoms are balanced. Now let's balance oxygen and hydrogen. To balance oxygen, we need to add water. Let's see how many oxygens are there. 3 2s are 6 oxygens over here, and 3 3s are 9 oxygen. So there are 15 oxygen molecules over here. And here we have 6 3s are 18 oxygen molecule. So let's add water molecule to the side having less number of oxygen. So here I will add 3 molecules of water. This will make up 18. Next, see the molecules of hydrogen. 3 2s are 6 hydrogen, 3 3s are 9 hydrogen, and 3 2s are 6 hydrogen. This makes up 15 and 6 makes up 21 hydrogen. Here I have 6 3s are 18 hydrogen. Now 18, so I have to add 3 H plus ions over here to make it balance. But since the reaction is in basic medium, the fourth step says that add OH ions equal to the number of H plus ions on both the sides of the reaction. So I will add here 3 OH ions and here 3 OH ions, and therefore I have the reaction in basic medium. Now this 3H plus and this 3OH will convert into 3 molecules of water, and I can cancel that out, and this 3 molecules of water will be cancelled out, and finally I get my balanced equation. I hope you understood the oxidation number method, and you can have the look on the steps once again. Now let's move on to our next method, that is half reaction method or ion electron method. The steps involved in half reaction method or ion electron method are: write unbalanced equation for the redox reaction and assign oxidation number to all the atoms in the reactants and products. Then divide the equation into two half equations. Step 2. Balance the half equation for oxygen atom by adding water to the side with less oxygen atom. Balance hydrogen atoms by adding H plus ions to the side with less H plus ions. Step 4. Balance the charges by adding appropriate number of electrons to the right side of oxidation half reaction and to the left of reduction half reaction. Step 5. Multiply half equation by a suitable factor to equalize the number of electrons in two half equations. Add the two half equations and cancel the number of electrons on both the sides of the equation. Step 6. If the reaction occurs in basic medium, then add OH minus ions equal to the number of H plus ions on both the sides of the equation. Then the H plus and OH ions are same side of the equation combined to give water molecule. And the last step, seventh step, check the equation is balanced in both the atoms and the charges. Now let's apply the steps to some examples. The first example, Mn plus 2 plus ClO3 minus gives MnO2 plus ClO2. So we have the skeletal equation in front of us. Now write the oxidation states. Here Mn is plus 2, Cl here is plus 3, oxygen here is minus 2. So this is our skeletal equation. Now let's assign the oxidation number. Here Mn is plus 2, here Cl is plus 5, oxygen here is minus 2, here Mn is plus 4, oxygen is minus 2, Cl is plus 4, and oxygen here is minus 2. Now let's divide this equation into two half reactions. First, let's write the oxidation half reaction. Mn plus 2 gives MnO2. So here it converts from Mn plus 2 to plus 4. This is your oxidation half reaction. Oxidation half reaction. That's why this is called as half reaction method. Oxidation half reaction. Now when it changes from plus 2 to plus 4, it gives out 2 electron. That is oxidation, loss of electron. And ClO3 minus converts into ClO2. Here it goes from plus 5 to plus 4 and the oxidation number decreases. So this is reduction half reaction. Now here the oxidation number decreases by 1, so we have to put 1 electron. Okay. Now let's balance the oxygen atoms. Here you have two oxygen. So I will put water molecule, 2 water molecules over here. And here I have 3 and here I have 2. So I have to add 1 water molecule over here. Now let's balance the charge. Here you have 2 electrons. Here I have just 1 electron. So I'll multiply this by 2. So I'll have 2, 2, 2 and 2. Now see for the H plus ions. Here I have 4 H plus ions, 4 hydrogen atoms, and here I have 4 hydrogen atoms in the second reaction. So first I will add the hydrogen ions over here, 4 H plus ions, and here I will add 4 H plus ions. Now the two reactions are balanced. Now just add them. 2H2O plus Mn plus 2 plus 2ClO3 minus plus 2 electrons plus 4H plus gives MnO2 plus 2 electrons plus 4H plus 2ClO2 plus 2H2O. Now let's cancel what is common. 2 electron, 4H plus, 2 water, 2 water. And ultimately you get your balanced chemical reaction, that is Mn plus 2 plus 2ClO3 minus gives MnO2 plus 2ClO2. And I guess the charges are also balanced. Here plus 2 charge, here minus 2 charge, here it is neutral. And Mn 1 Mn, 2Cl, 2Cl, 3 2 is 6 oxygen, here 2 plus 4, 6 oxygen. So ultimately you get your balanced chemical equation. Easy. Let's move on to the next example.
Cr2O7 minus 2 dichromate ion plus SO3 minus 2 sulfite ion gives Cr plus 3 plus SO4 minus 2 sulfate ion. So let's assign the oxidation state. Here chromium is plus 6 each, oxygen is minus 2 each, sulfur here is plus 4, oxygen minus 2, chromium here is plus 3, sulfur here is plus 6, and oxygen here is minus 2 each. So let's write the oxidation half reaction. The oxidation half reaction Here SO3 minus 2 is converting into SO4 minus 2. So SO3 minus 2 converts into SO4 minus 2, and reduction half reaction, the reduction half reaction is Cr2O7 the whole minus 2 to Cr plus 3. Now once we have identified the reduction half reaction and oxidation half reaction, let's now go on to the next step. Balance the oxygen atom. Here you have 3 oxygen, here you have 4 oxygen, so we'll balance it by adding a molecule of water, H2O, and here there are 7 oxygen atoms, so therefore add 7 H2O to the other side. Next, balance the hydrogen atoms. Here you have 2 hydrogen, so I will add here 2 H plus ions, and here I have 7 to the 14 hydrogen atoms, so I will add 14 H plus ions. Next, balance the charges. From plus 4 it has gone to plus 6, so it has undergone oxidation by loss of 2 electrons, and here it has converted from plus 6 to plus 3, so it has gained 3 electrons. So here 3 electrons. Now balance the chromium atoms as well. Here you have 2 chromium, here you have 1 chromium, add 2 chromium here, and since one chromium atom receives 3 electrons, so when you have 2 chromiums there will be 6 electrons. Now balance the electrons. Here you have 6, here you have 2, so multiply this equation by 3, so this makes up 3 3 3 3 2s are 6, so here I will get 6, and here I will get 6 electrons. Now final step, let's add 3SO3 minus 2 plus 3H2O plus Cr2O7 the whole minus 2 plus 14H plus 6 electrons gives 3SO4 minus 2 plus 6H plus 6 electrons plus 2 Cr plus 3 plus 7 H2O. Now let's cancel off whatever is common. 6 electrons, 6 electrons. Then we have 3 molecules of water here. You have 7 molecules, so this will become 4. Next you have 6 H plus ions here. You have 14, so minus 6 from here makes up 8 H plus ions, and that is your balanced chemical equation. In our next example, we have hydrogen peroxide reacting with perchlorate ion to give chlorate plus oxygen. Let's assign the oxidation state. Here hydrogen is plus 1, here oxygen is minus 1 each, here chlorine is plus 7, here oxygen is minus 2 each, here chlorine is plus 3, and here oxygen is minus 2 each, and oxygen here is bonded to itself free, so its oxidation state is 0. Now let's write the oxidation half reaction. So the oxidation half reaction is H2O2 gives O2. So minus 1 to 0, there's an increase in oxidation number, and next is the reduction half reaction, which can be written as ClO4 minus converting into ClO2 minus. Okay, now let's balance the hydrogen. So here you have two hydrogen, so add two molecules of water, sorry, two H plus ions over here. And for oxygen, here there is four oxygen, here there is two oxygen, so add two molecules of water. On doing so, you added four hydrogen atoms as well. So I will balance that by adding four H plus ions over here. Next, balance out the number of electrons. Here I have lost electron, so here plus 2 electron, and here from plus 7 I have reached to plus 3, so here you will have 4 electrons. Now here there are 4 electrons, here there are 2 electrons, so multiply this equation by 2. So this makes up 2H2O gives 2O2 gives 4H plus. Where is this? So this will now become, and this will also become 4. So here it will be 4 H plus ions, and here it will be 4 electrons. Now see the balancing: 2 hydrogen, 2 oxygen, 2 oxygen, 4 hydrogen, 2, 2, and 4 electrons. Here you have ClO4, here you have 1 Cl, 1 Cl, 4 oxygen, 2 plus 2, 4 oxygen, 4 H plus and 4 H plus, and your 4 electron. Now it's time to write the overall reaction. So when writing the overall reaction, just add all of them up, and now you have 2H2O2 plus ClO4 minus plus 4H plus plus 4 electrons gives 2O2 plus 4H plus plus 2H2O plus ClO2 minus plus 4 electrons. So whatever is common, just cancel it off. 4 electrons, 4 electrons, 4H plus, 4H plus. Just check: 4 hydrogen atoms, 4 hydrogen atoms, 4 oxygen plus 4, 8 oxygen. So here you have 2, 2, 4, and here 4, 8. 1 chlorine, 1 chlorine, and the charges: 1 negative charge and 1 here negative charge. And finally you get your balanced equation. I hope you liked. Thank you so much for listening. Please put your valuable comments below, and I hope you like, share, and subscribe to my channel, and wait for some more interesting videos. Bye.